Hi, this is Mr. Manley, and this is a video on finding the coordinates on the unit circle for special angles. When we're talking about special angles, we are referring to any angle that is a multiple of pi over 6, pi over 4, pi over 3, pi over 2, and don't forget pi itself. Any angle that is a multiple of one of these angles can be found on the unit circle. And if you are given the unit circle, this is really a pretty simple problem once you've determined that you're working with a correct multiple. Now, it has to be one of these multiples. There's no way I can work a problem like this with a multiple of pi over 7. So if I were asked to find the coordinates on a unit circle for pi over 7, that's not a problem that I can answer, not a problem that I can ask. Let's take a look at what's been given here. In this problem, we are given here 5 pi over 4, and we're just asked to find the point on the unit circle. They're calling it the terminal point. It just means the point on the unit circle where the angle, the terminal side of the angle, intersects the circle. So I can just take a look at the 5 pi over 4 and look for 5 pi over 4, and I will find it here on the unit circle. And then I'm just being asked for that associated point. The associated point there is radical 2, or negative radical 2, over negative radical 2. That's simply the x and y coordinate of that point. Pretty simple. Let's just take a look at another example, and then we'll look a little bit at where the unit circle comes from. So let's just say that I was going to do something like 16 pi over 3. Now in this case, 16 pi over 3, if I look for it on the unit circle the way I did the other one, I'm not going to find that specifically. So I'm going to be finding an angle on the unit circle that is coterminal with this angle, and that is a concept that you should have seen already if you're watching this video, and you should know how to find a coterminal angle. Taking the 16 pi over 3, I'm going to write the 16 pi over 3 as a mixed number, so that will be 5 1/3 pi. And then watch how I'm going to find the coterminal angle here. I'm going to go starting at the, well, let's go ahead and get an initial side of the angle here. Get a nice color that we can see very clearly. So here I am. If you look at the unit circle on the right side of the unit circle, and I lost it. Let me get that back. All right, so I'm over here on the right side of the unit circle, and if I rotate around the unit circle, rotate around the circle, there, halfway around, that's pi. We should know that. Half of a circle is pi. Now I want to do 5 of those. So I keep going around. There's 2. There's 3. There's 4. There's 5. And then I want to go another third. Another third of half of a circle, and that's going to land me right there. And then it's a simple case of looking at the x and y coordinates that are with that. So the terminal point on the unit circle that is determined by 16 pi over 3, which is coterminal with 4 pi over 3, is whatever the coordinates of that point are. It's negative 1/2 negative rad 3 over 2. So pretty simple if you understand what's being asked and understand how to use the unit circle. I just briefly want to take a look at the unit circle, and I just want you to have a little understanding of where the unit circle comes from. Again, if you've been studying some trigonometry, this should be familiar to you. It is the convenient angles that are the multiples that we know, pi over 6, pi over 4, pi over 3. The circle itself, what we have to agree to get to where we're talking about a unit circle is that this circle has a radius of 1. And that is an agreement that we have that we're going to talk in terms of a circle with a radius 1. And if the circle has radius 1, that means that on an xy axis, this point here would be 0.10. And then just now, having established that, I could potentially find the x and y coordinates of other points that are on this xy axis. So if you look at this, if I go over x, this distance x, and then I go up this distance y, that gets me to that point that intersects the circle at an angle of pi over 6. So if I take the angle pi over 6 and I rotate that much, it intersects the circle at that point. And we can see that the x coordinate, or the x distance of that point, it's a little less than 1. And the actual value, the exact value, is radical 3 over 2. And if we go up in the y direction, you can kind of see that I'm about halfway up from the origin to this point up here, which we should also know to be 0.01, right? That should be obvious. If the circle maintains its radius of 1, this point up here is going to be 0.01. And we're about halfway up that line on the y-axis for this point at pi over 6. So that's 0.1 half. Let's just take a look at one more. If I take this point here, and I want to know what's the x and y coordinate there, so I go over a certain distance in the x direction, and I go up a certain distance in the y direction. And we could use some geometry, and if you recall, there's something called special triangles from geometry, and we would be able to figure out that that coordinate there is exactly rad 2 over 2 for the x coordinate and rad 2 over 2 for the y coordinate. So this unit circle can make sense, and we could be able to build this on our own. But for our purposes, we're going to want to be, if you're given the unit circle, we want to be able to use it to answer some questions.